Hello and welcome back. Today we're going to be talking about solving multi-step equations. The objective is that by the end of this video, you should be able to solve equations that require multiple steps to solve. As is usual, we have some vocabulary to discuss first, and that first vocabulary word is the distributive property. Rather than give you a formal definition of the distributive property, I'm going to show you some examples to demonstrate how the distributive property works. If you have a number next to a set of parentheses, then what you're going to do is you're going to multiply that number by every number inside of the parentheses, or every term inside of the parentheses. Notice this is going to be different from when we distributed exponents in previous lessons. Let's take a look. 3 times 4x gives us 12x. 3 times negative 5 gives us negative 15. Again, we were doing nothing with the exponents because there was no exponent outside of the parentheses. Let's take a look at a second example. Suppose there's a negative 2 outside of your set of parentheses. Again, you just distribute the negative 2 into every term inside the parentheses. Negative 2 times negative x gives you a positive 2x, because a negative times a negative is a positive. Then we get negative 2 times 4x to the fifth, gives us negative 8x to the fifth. Again, please notice that the exponent was not changed because there was not an exponent outside of the parentheses. Let's take a look at a third example, 3 minus, and then I have a set of parentheses. There is a negative 1 right here. So anytime you have a negative in front of the parentheses, it's understood that there's a negative 1 coefficient that you then distribute. So we get 3 minus 1 times 2x squared gives you a negative 2x squared. Negative 1 times negative 4x gives you a positive 4x. And negative 1 times positive 7 gives you a negative 7. Please note that the 3 was not being multiplied by anything inside the parentheses, since the 3 was not multiplied by the parentheses themselves. To further demonstrate that, let's take a look at a non-example of the distributive property. 3 plus parentheses 2x minus 4. Notice the 3 is not being multiplied by the parentheses, and there's just a plus sign in front of the parentheses. So we know that there's a coefficient of 1, but if you distribute a positive 1, it does not change the value of anything inside the parentheses, leaving us with just 3 plus 2x minus 4. Notice the expression has the same value with or without the set of parentheses. Alright, like terms. Like terms are like variables, in other words, the same variable with the same exponent, and also all constants are also like terms. So let's take a look. Which of the following are like terms? Please circle and underline the like terms. I'm going to circle the x squareds. 3x squared is a like term with x squared is a like term with negative x squared, because they are all the same variable, x, and they all have the same exponent, 2. Additionally, 3 is a like term with 2 is a like term with negative 3, because they are all constants. A constant is a number without a variable. Let's take a look at our last two, 3x and x. They are also like terms because they are the same variable, x, and they have the same exponent, an understood 1. So then combining like terms means that you just add or subtract your like terms. Combining like terms can be understood as simplifying. In this example, we're going to try to combine our like terms, which are 3x squared and x squared, negative 4x and 5x. We have a bit of an issue though. You cannot combine your like terms until you have gotten rid of the parentheses, because the 5x and x squared are trapped inside of the parentheses. To get rid of the parentheses, we need to use the distributive property. So I'm going to go ahead and rewrite the first part of the expression. Then I'm going to distribute the negative 1. So 3x squared minus 4x minus 5x minus x squared plus 1, because a negative 1 times a negative 1 is a positive 1. Now that I've gotten rid of the parentheses by using the distributive property, I can combine my like terms. 3x squared and negative x squared. Notice I have 3x squareds and a negative 1x squared. What is 3 minus 1? The answer is 2, so I have 2x squared. Let's combine our next like terms. Negative 4x. Is there any like term with negative 4x? Well, yes, there is. It's negative 5x. So negative 4x's and negative 5x's gives you how many x's total? Negative 4 plus a negative 5 gives you a negative 9x. Then we have the 1 left over. Since the 1 has no other constants to combine with, we just write plus 1. Please go ahead and try to combine the like terms or simplify the expression below on your own. Press pause, and when you're ready to see the answers, please press play. Hopefully the first thing you chose to do was to get rid of those parentheses, so you distributed a negative 3 into the parentheses, leaving you with 4 minus 3x minus 12x squared plus 5x minus 7. We can now combine our like terms. I'm going to start with the largest exponent, so let's take a look at our negative 12x squared. Since there are no other x squareds, I can just write that over again, negative 12x squared. Let's take a look at our next like terms, negative 3x and positive 5x. Negative 3x's plus 5x's, so 5 minus 3, gives us a positive 2x. Our last like terms are our constants. We have two constants, a 4 and a negative 7. 4 minus 7 gives us negative 3. And here we have combined our like terms. As a quick review, since we're going to need it for this video, let's talk about reciprocal real quick. Reciprocal, or the multiplicative inverse of 2/3, is 3 over 2. The reciprocal or multiplicative inverse of negative 3 over 5 is 5 over negative 3. Again, the reciprocal or multiplicative inverse means that you flip the fraction upside down. Let's talk about solving again. In order to solve, the rules of the game are that you must simplify both sides of the equal sign first. You must do opposite operations in SADMAP order, and please keep trying and checking your answer until you succeed. Here's our first example. Let's solve 6 equals negative x minus negative 2x. If you look back at your rules, the first statement says that we must simplify both sides of the equation first. So I'm going to simplify the left-hand side first. 6. There's nothing you can do with 6, so we just rewrite 6. The right-hand side of the equation, however, has two like terms, the negative 8x and the negative 2x. However, the negative 2x is trapped inside of parentheses, so we need to distribute the negative 1. This leaves us with negative 8x minus 1 times negative 2x gives us a plus 2x. So 6 equals negative 8x plus 2x, which is negative 6x. In order to solve the equation from here, now that we've simplified both sides of the equation, we solve using the reverse order of operations. We need to undo the negative 6 times x. To do that, we divide both sides by negative 6. 6 divided by negative 6 leaves us with negative 1 equals 1x, or just x. As is usual, I ask that you check your solution, so we check it. 6 equals negative 8 times negative 1 minus negative 2 times negative 1. So 6 should equal negative 8 times negative 1, which is 8, minus negative 2 times negative 1, which is positive 2. So 6 equals 8 minus 2, which is 6, and our solution checks out. Let's solve a little bit more complicated problem. Again, the instructions ask us to simplify the left-hand side and right-hand side first. and then to go ahead and solve by reverse order of operations. Please, on your own, if you feel like you can do it, pause the video, work this problem out, and then press play when you're ready to see the answer. Otherwise, let's go ahead and work it together. We must combine our like terms or simplify the expression, but both m's are trapped in parentheses, so we're going to have to use the distributive property twice. This leaves us with 3m plus 3 times 1 is 3 minus, notice this is a minus 4 outside the parentheses, so I'm going to need to distribute a negative 4. I can demonstrate that a little bit better by making the outside of the parentheses a plus negative 4. So negative 4 times 2m gives us negative 8m. Negative 4 times negative 6 gives us 24. Now that we have no more parentheses, we can combine our like terms. 3m and negative 8m gives us a total of negative 5m's. Plus 3 plus 24 gives us plus 27 equals negative 11. We're now going to solve in SADMEP order. SADMEP tells us we need to undo subtraction and addition first. So we're going to undo this plus 27 by subtracting 27 from both sides of the equation. This leaves us with negative 5m, because 27 minus 27 is 0, equals negative 11 minus 27 gives us a negative 38. We can solve it the rest of the way by dividing by negative 5, and we get m is equal to negative 38 over negative 5, which can be written as 38 over 5. Let's take a look at another example. Solve for b. In parentheses, I've said a clever way to avoid adding and subtracting fractions, sometimes. Sometimes this works, sometimes it doesn't. Notice this problem has a 2/3 outside the parentheses. If you choose to distribute that 2/3, you're going to end up with two fractions that you're going to have to mess with in order to solve. There's a clever way we can avoid distributing that 2/3. Let me show you. Notice I'm leaving myself a space between the 2/3 and the equal sign. It's because I'm going to use that space to multiply both sides of the equal sign by the reciprocal of 2/3. 3 halves, negative 12 times 3 halves. This gives us negative 12 over 1 times 3 gives us negative 36 over 2 equals 6 over 6 times 4b minus 5. Working it out further, negative 36 over 2 is negative 18. 6 over 6 is 1. 4b minus 5. Now, by multiplying by the reciprocal of the fraction outside the parentheses, I was able to turn that 2/3 into a 1, which is a whole lot easier to distribute. All I'm left with is negative 18 equals, distributing the 1, I get 4b minus 5. And that's pretty easy to solve. I just add 5 to both sides. Negative 18 plus 5 is negative 13 equals 4b. Then I can divide both sides by 4. And I'm left with b equals negative 13 over 4. Again, it's always a good idea to check your solution. I'll leave that to you to go ahead and check that out. Here's an example for you to try. Go ahead and pause the video and press play when you're ready to see the answer. Okay, I got 23 over 4 as my answer, and I did that by distributing the 3, distributing the negative as a negative 1, giving me positive x, and then minus 2. Combining my like terms, 3x plus x is 4x, negative 15 minus 2 is negative 17. Adding 17 to both sides, and then dividing both sides by 4. And again, please check your solution. Here's another example for you to try. Hopefully you saw that fraction outside the parentheses and decided that you wanted to get rid of it by multiplying both sides by the reciprocal. The reciprocal, by the way, of negative 3 over 5 is 5 over negative 3. So I'm going to multiply both sides by 5 over negative 3. 5 over negative 3 times negative 3 over 5 4a minus 5 equals 3 times 5 over negative 3. I have to put the 3 over 1. Gives me 5 times negative 3 over negative 3 times 5 is just 1, which we don't have to write. So I'm left with 4a minus 5 equals 3 times 5 is 15 over negative 3. So 4a minus 5 equals negative 5. Add 5 to both sides, you get 4a equal to 0. Divide both sides by 4, and you get, again, 4a equals 0. 0 over 4 is 0, so a is equal to 0. And that one's pretty easy to check out, because 4 times 0 is 0 minus 5, so you get negative 3/5 times negative 5, which does equal positive 3. Here's a couple problems that are a little interesting in that they're different from the problems you've seen in the past. Let's put the first one, negative k plus k equals 21. Negative k plus k is 0 equal to 21. You cannot solve this equation. There's no variable left to solve for. Not only can we not solve it, but we're left with a statement that's not true. Since this statement's not true and we have no variable to solve for, we say that there is no solution. Again, this only really happens when all the variables go away and you're left with two numbers that are not equal to each other. Please take a look at that last example, try to work it out on your own, and press play when you're ready to see the answer. Alright, hopefully you chose to, oh wait, can't exactly multiply both sides by 5/3. If you tried it, it's okay. I set up this problem on purpose because there's a 2w out here. You'd have to combine like terms before you could multiply both sides by 5/3. So we would be left with 3/5 times 5w gives you 3w. 3/5 times negative 10 gives us negative 6. Plus 2w equals 5. 3w plus 2w is 5w. Minus 6 equals 5. Add 6 to both sides, we get 5w equal to 11. Divide both sides by 5, and we're left with w equal to 11 over 5. So again, the only reason this problem worked out the way it did is because you had to combine your like terms first on the left-hand side before you could start solving.